So this is part 3 of a 3-part series of videos to build your analysis, visualization, and data cleaning skills. This one's going to focus more on the visualization side. Okay, so we'll open up RStudio and go open that project again and find your files down in the lower right corner and open Permits Notebook again like we did before. Just like the previous one, we need to run our code that is installing those libraries, loading those libraries and loading the data. So hit pause on the video and go through and run any of the chunks of code where we are cleaning or changing our data in any way, like these where we adjusted the names, where we added columns, and things like that. Okay, so you should have permits and permits by year at least. You might also have anything. Yeah, we didn't make anything else, did we? So now we're going to move on to Ggplot, which is the tidyverse version of making plots or graphics or charts in R. So we're going to start with I like to build up on Ggplot, and instead of giving you a big huge chunk of code at first, we start with just the most basic things you need to know to do Ggplot. You probably saw some of this basics in a previous video, but I always think it's worth repeating again. So the basic syntax of Ggplot is that you give it the name of the data frame that you want to reference, and then you give it what's called the aesthetics. And the aesthetics are, the main ones you need are an X variable and a Y variable. The X is usually whatever's going to go across the bottom of the chart, and the Y is usually the value that you're plotting, like in a bar chart or a line chart, and so it kind of represents what's going up and down on the vertical axis, the Y-axis. And then you use a plus sign at the end of each line of code to pipe together your various operations. And then in the second line, you give it what kind of plot you want to make. So there's geom line, there's geom bar, geom column, geom point. There's a whole bunch of them. If you just Google Ggplot, you can see all the different variations that you can do here. And then this stat equals identity is needed. The way I don't fully understand what this is doing, except that it is connecting back to the aesthetics up in the data in the first line of code. There's ways to do more complicated ones where you actually have more than one set of data. So like you can plot an extra line over the top of a bar chart or something to show a trend or something. And that's when things start to get complicated. But this is just the really basic things you need for Ggplot. So let's run this and see what we get. So what this is doing is plotting the number of single family, that's SFD, how many units were built each year in total. Remember, permits by year is, we already summarized it for the whole metro. So this is representing the whole metro area. And this simple bar chart, it doesn't have anything too fancy here, but it does seem to have some issues that we could address. Let's start with making it a little prettier. How about some color? And we can adjust the size of that line even. So if we scroll down, I've started baking out more and more code as we go along. So I've added color equals blue, size, you can make that like 1.5 or 2, and we can see how much bigger that gets. You can play around with that. You can even do like 1.25 if you don't like 1.5. So, and that the color, there's colors baked into R that you can reference, or you could put in a hex color code. There's all kinds of hex charts on the web. I like to use a site called colorbrewer2.org to get hex codes. So you could put that right in here instead of the word blue, for example. Okay, let's move down to the next section. So you can see that the first 2 lines of code here are the same as what we've already done. I just keep adding lines of code to improve our chart as we go here. So this section is going to work on the axes, the X and Y. So let's look at the X-axis first. That's a simple one. The exact code that you would use for this is going to be dependent on what kind of data you have. We have what's called continuous data, 1970, 1971, 72, 73, etc. So it's numbers that go in a sequence. If you don't have continuous, it would be what is probably called discrete. So let's say we were wanting to plot the total number of single family, the total as one bar, the total duplex is another bar, the total townhomes is another bar. Those buckets would be discrete and they wouldn't be following a continuous pattern. And in that case, you would use a function called scale x discrete. And these are things you can look up online when you need them. I find, I tend to use the continuous one more often than not because I'm often charting years and things like that. So then some of the things here in this that you can do, you can name set the label that goes below the axis. This breaks equals SEQ is how you tell it what these labels are going to be on the bottom. Notice on the chart we just ran with the default options, it just put the labels in every 10 years. What we can do in here is we're saying start with 1970, go to the year 2020 and list every 5 years. And then here we can, the scale Y continuous is going to work on this Y axis, the vertical one, vertical one, sorry. Notice that it doesn't appear to start at 0, and I'm a little suspicious that just before the year 2010 that there were no single family homes being built. So I suspect that this is not 0 based. So let's make it 0 based. And the way we do it is with this limits. You say that it needs to go from 0 to whatever the top end needs to be. And this is where running this test one up above is really helpful because we can see that the highest point was about 12,500. So if we set the top end of this at 13,000, that should accommodate our chart pretty well. Now the breaks equals SEQ, again, is just like what we did with the years. We're telling it start at 0, go to 13,000, and display the numbers in increments of 2,000. So this is going to make more sense when you see it happen. So here you can see it goes from 0 to 2,000 to 4,000 to 6,000 to 8,000. And then it's showing every 5 years across the bottom instead of every 10. Now notice our data ends at 2019. I kind of fudged by putting 2020 as the endpoint. If we put 2019 as the endpoint here, it will not give us a label down here. There's probably some fancy schmancy way buried in the syntax of Ggplot to get it to show that last point. But I find this is a nice quick and dirty way to at least get it to show, especially if I'm just making charts either for myself or to share with my colleagues and not publish them. Okay, so this is looking a little better already. Let's add a title and a subtitle and a caption. We can do that with this labs function, and you can see you can put in there whatever things you want. So now it has created a title, a subtitle, and then the caption is down in the lower right corner. Looking a lot better already. Now one more thing, I like to use apply a theme from a package called Gg themes, and there's a whole bunch of different themes you can use. This one is a high charts theme. It goes with the website and the tool high charts. And this sets the font, and notice we've got now a better background and generally looks a little bit better. So you could play around with the different themes from Gg themes. You do need library Gg themes loaded, which we did up at the top of this chart in order for this to work. And there's other packages that offer other themes as well. There's a lot of them out there. So if you want a way to pretty up your chart without you having to do a lot of lifting in terms of styling, you can use a theme. It's a good way to do it. Now here, this line 355 is another little handy thing. When you have this chart run and displayed here, you can use ggsave to spit it out as a JPEG. And you'll see in the lower right corner now, there is a JPEG in your working directory, and it will be your chart. So it's a good way to share with other people. All right, let's start tweaking and playing with this a little bit more. So that chart we just made was measuring units, which is whole numbers. I want to chart that column we created called percent SFD, which is the percent of single family homes built each year. And I want to chart that on a line. So the syntax here looks a lot like what we just did, that geom line. This is almost identical to the first one we did. And then the scale X continuous is identical. The big change here is in scale Y. But I'm going to comment this out and run this for you so you can see what the problem is that we need to solve. Notice now the percentage is stored in our data as decimals. And so that's what it'll display on here unless you tell it otherwise. And there is a lovely way to do that using a package called scales. It has a percent function that you can apply to the labels using this syntax right here. Labels equals scales colon percent. And you could actually just say labels equals percent and it'll work. I tend to write it this way though to remind myself that I need the scales package loaded in this code in order for that to work. It won't work without that package. So let's run this now with the new code. There we go. Now we've got percent labels, and it's actually got the symbol, percent symbol, a lot prettier than that last one. Okay, so let's move on and look at multifamily units built each year. Remember how we have the MF3, the MF5, the DUP and DTX, all these different definitions. Well, we might need to do some data cleanup to get to make a chart with just multifamily. So I was thinking, well, maybe we should just combine together everything that's 2 or more units. So the duplexes, the triplexes, the multifamily, and all the multifamily iterations here. So we're going to add on 2 new columns here, one called 2+ and one called %2+, where we're doing the math to create a percent. So this is using mutate just like we did above. And so our new permits by year should have some new columns on them over here. %2+. So now we can go back to our chart. This time let's make this a bar chart instead of a line chart. So the big change here is geom bar. And you notice our y-axis is now that %2+. And then the other thing is this color and fill, and I'm going to explain that in a second. I'm going to comment out these 2 lines just so we can see what a real basic chart is going to look like. If you don't do anything with these things. So the way this syntax works is the color is actually the outside edge of the bar, and the fill is the inside. So if we changed color to orange, for example, we won't see the separations between the bars very well, unless there are some ways to make those bars wider or narrower so there is a separation between the 2. For now, I'm just going to leave this as black. And then we will, the scale X continuous and scale Y continuous again. The X one is the same as what we've had before because we're still dealing with the years and it's still continuous. And our Y is like that last chart we did. We're going to make it as a percentage as well. But this time it's a bar chart instead of a line chart. And we do have quite a bit of white space up here. Maybe we don't want the limits to be set to 1. Maybe we want to do 0.8 so that the chart isn't quite so high. Or maybe even, you could even do 0.75. Notice I'm doing point because that's how it's stored in the data. Previously the 0 to 1 meant 0 to 100%. Looks like 0.75 is not going to work for us. Notice we don't really have a top end of our scale. So 8 is probably a good place to stop. We do have our labeling issues down at the bottom. This one's going to be trickier because you don't really have a 2020 bar. So we'd have to figure that one out, especially if you wanted to publish this. Okay, so here, your turn. Come up with a chart, pick a chart type, bars, lines, whatever, and chart how many townhomes were built each year. Remember, townhomes is the column called TH in here. There it is right there. And make a chart and then come back and see the answer. Okay, so I cheated a little bit and I just stole some code from one of the line charts we made above, and I changed the y-axis to TH and I changed the labels here. I'll run it quick and you can see that we've got tons of white space here because I left the limits and the breaks set to 13,000, which is what we used for the single family homes. There's a lot more single family homes than townhomes. So we could leave it like this just to give, if you wanted to get some scale compared to that other one, or you could adjust it to something lower, like maybe 8,000, and see how that looks better. 8,000 even is still really high, but you get the idea. But you do want to make sure that limits is set to 0 so that it works properly. You will get especially on ones like this. I'm going to take this off for a second. You will get some serious craziness. Look at this. It makes these peaks and valleys look much bigger than they really are when you don't zero base your chart. So that's super important. There we go. Okay, let's move on. So earlier we did pivot wider, but they also have pivot longer, which will take this wide data, which is what we have here and now in our permits by year table, and turn it into longer. And it's quite common for us to get data that does come to us this way with this wider format. And sometimes we need to make it longer. A particular case where we do need to make it longer is if you wanted to make something like a multiple line chart or a stacked bar chart or a grouped bar chart. In those situations, R and Ggplot want your data to be more simplified and that there's really only one value column instead of separate value columns for each thing. So that's what pivot longer would do for you. So pivot longer syntax is a little bit different than pivot wider, but still enough similar. And like pivot wider, it wants a very succinct data set. It really only wants the things that you truly want to pivot. So in this case, I'm telling it just to select the year and those original columns that we started with. I'm not going to include our total and the percentage columns that we calculated, all those things that we added. I'm not going to take them. I'm just going to tell it to only take those columns. And the syntax here with pivot longer is that you first give it the table or the data frame that you want to work with, and then a pipe. Then you do pivot longer. Remember with pivot wider, it was the other way around. And then the first argument inside the parentheses for pivot longer is which column do you want to kind of hold in place, basically. In this case, the year. You want to keep it going down as the year. And then it will what's going to happen then is that it's going to automatically convert all those other columns now into rows. So what what's going to happen then is we need to tell it, well, what do you want to call that new column that's going to house these labels? And what do you want to call the column that's going to house the values? And this will make more sense when you see it happen, but you need to give it names here. And this can be whatever you want. Inside these quotes, it's a name that you make up. So this is something I made up. So let's run this. And permits longer. So now you can see that we have multiple rows for each year, one for each type of housing type, and then the values are showing up in our total units column. So what effectively happened is it took those column labels, dupe, MF3, MF5, and now made them values in this column. And then the corresponding unit numbers are in the other column. So this is longer data. It's also referred to as normalized data or tidy data, and a lot of computer programs like data in this format versus wider. So this comes in handy if your data comes to you wide and you need to make it long. So now that we have it long, we can try to make what I talked about, a multiple line chart showing how much multifamily was built versus how much single family was built each year over time. So we're going to start by collapsing down the various unit types into more of a multifamily and a single family and an other. So anything with kind of 2 or more, we're kind of grouping together. And we probably could have, in hindsight, I realized we could use that 2 or more column, but here's another chance for us to recode. And this might be something new to you. Right here, with this in with the two percent signs around it is a way to do, to have it look for multiple unit types in this case. So this is saying if the unit types columns has either duplex, MF3, MF5, or DTQ, then we're going to call that MF in our new column that we're creating. And the C in front of your list of things is ours way of indicating, hey, I've got a list coming at you. And inside the parentheses will be a list. That's what the C is doing. So we're rebucketing all of those things as MF. We're recoding SFD to just SF. And then everything else is going to be labeled other. And that's going to be the townhomes and the ADUs. So let's run this. And then if we look at our new permits longer, we've got that new column now. And so instead of having like 7 rows for each year, we need to knock it down so there's 3 rows for each year, just an MF row, an SF row, and an other row. So we need to group it and make a new table. So that's what this code is doing. Grouping by year and the type new. We're going to ignore our original unit types column. We're going to just leave that all out of the equation altogether. Regroup it, re-summarize it into a new table. So permits longer chart now has much fewer rows, only 150 rows. And you can see there's 1, 2, 3 for 1970, 1, 2, 3 for 1971, all the way down the line. Perfect. So now we can go start working on our line chart. But first I wanted to talk about the order that your values appear in here. You can see right now it appears to be going MF, other, SF, MF, other, SF. But when we start to make our chart in a minute, I'll show you in a minute why, we're going to need to ensure that it's definitely in a particular order. And sometimes you might want it to go in an order that is very specific to you. And to do that, it's called setting the factor order of a column. And this is some base R syntax that will set that factor order in a situation where you have discrete values like SF, other, MF. We don't have continuous. There's some different syntax if you wanted to ensure that you wanted to sort something based on numeric values that are stored in the data. There's other syntax that you can use. But simply know that it's called setting the factor order. Once you know that, then you can go find the right syntax for your particular situation. So in this case, we're going to set it so it goes SF other MF. Run that. And now here's where it comes into play. So I'm going to move this up a little bit for you. So I want to make a multiple line chart. So we're going to have 3 lines. One's going to be for that multifamily, one's for single family, and one's for other. So I'm going to first comment out the scale color manual so you can see what's going to happen without it. If we run this, what's happened is that R has selected just some default colors and given it to each line, and it's we've set the y-axis. We didn't set the x-axis though, did we? So it's showing every 10 years. We could fix that, of course. But the big thing that you need to know is that the aesthetics here now have a third thing, and that's color equals type new. This is the particular syntax for indicating what you want the lines to be, and it's the colors. So the colors being set based on whatever's in the column called type new. If you were doing stacked bar charts or grouped bar charts, there's some other syntax. It's different, but the concept is the same, that you're adding a third thing to your aesthetics. And then with the bar charts, there's some other things you need to add into the geom bar line of code as well. But for now, we're going to work on these lines. Now, this is where the factor order really comes into play, is that we can use scale color manual to set what those colors of those lines are going to be, and we can ensure that we can change these labels. Instead of SF, other, and MF, we can give it something more reader friendly, like the full name. So the key here is that we set the order up above as SF, other, and then multifamily. And so when you put these labels in, you have to put them in the order that they are in the data. And if you didn't do the factor order, there's no way to know what the order is unless you somehow can figure it out from the chart. But let me tell you, it's not easy to figure out. So you want to set that factor order before you do like the scale color manual. So what we're doing here is saying, here's the colors we want for, the first one is going to be for single family, the second one is for other, and the third is for multifamily, and then label them accordingly. So now let's run this. And we got much prettier colors that actually go together, and the labels down at the bottom look a whole lot nicer. What I didn't do here is do anything with this legend. There's a whole bunch of things you can do. You can change what this label is going to be. Instead of type new, you can have it be something else. You can have it be on the side. You can have it be on the top. You can have it be in more like a box kind of thing. The options are pretty wild. So, but I didn't cover that here. You can look that up in Ggplot legend, and you'll find lots of directions on how to do that. So now that we've finished our page, let's hit save. And if you've now got an HTML file in here, it should have updated just a second ago. I'm going to open that up in a web browser, and you'll see that it has, remember at the top I made these notes with break tags at the end, and it's showing your code and then the results of your code right in line, and you can troll right through your results. And if we go down a ways, you'll get to see your Ggplots right in here as well. There they are. And so now this is an HTML page that you could email to somebody. You could put it on a server. You can share it with your colleagues. There's so many, but it's nice and pretty. And this is also a good way if you're working, if somebody's teaching you R, you could send this to them and say, hey, did I do it right? Or why is this not working? And they can see what you're getting and also see your code at the same time. So that's the beauty of a notebook file. That is the end of my lesson. I hope you enjoyed it. Thank you so much.